Welcome to Fun with Science, Engineering, and Technology. I'm Mr. Ross. My assistants this morning are Samir and Claudia. So what we're going to do is we're going to launch marshmallows. That's our big scientific project for today. Don't laugh. It's going to be a lot of fun. First of all, what we're going to do is we're going to start out with a standard marshmallow. What's a standard marshmallow? It's not one of those little teeny tiny ones, right? But it's this size, right? And what we should really know is a little bit about, see if we can figure out a little bit about our marshmallow. What would you think we might want to know about it?
It's round.
It's round, all right? We might, if we really get really scientific with it, we might want to measure the dimensions, make sure it's going to fit our launcher. What else do we need to know about it that's probably more important than the dimensions of it?
It's lightweight.
How much it weighs, right? But I don't have a scale. How am I going to find out how much it weighs?
I don't know.
You don't know? Let's look, see if we can get a hint. Right. On all the packages that we have nowadays, it has some nutrition facts, right? And it tells us something about the marshmallows and what kind of nutrition they have. It's up here in the left-hand corner. It says nutrition facts. Right. One of the important things about nutrition facts is what is the serving size, right?
Yeah.
Like how much nutrition you're going to get depends on how many marshmallows you eat, right? If you eat the whole bag, you're going to get more nutrition than if you just eat one marshmallow. So we need to know what the serving size is. And Samir, what's the serving size? You find it on here? A little fine print up
4
on the top.
pieces, 30 grams.
Okay, 4 pieces. In other words, one serving size.
30, about.
All right, is 4 pieces, and those 4 pieces weigh about 30 grams, all right? I'm sure that whenever they make these marshmallows out of the marshmallow making machine, they're not all going to come out exactly the same size and the same weights, all right? So but it's approximately, all right, 30 grams. And so what's each marshmallow weigh? We'll let her do the work, right? You and I are going to be the stars. She can do all the work. So we're going to take 30 grams, we're going to divide it by 4, and we're going to find out what each marshmallow weighs.
About 0.13.
All right, point what?
13.
0.13? 4 into 30?
Wait, hold up.
You don't like this math stuff, do you?
No.
You got to have the math, all right? If you're going to do science, you got to have math.
0.1. Wait, here.
What? All right. Let me try it. 30 divided by 4 equals?
Oh, 7.5.
7.5 grams, all right? So that marshmallow weighs 7.5 grams. Okay, now, how many marshmallows are in the bag? You put the bag down. Come on. How many marshmallows are in that bag? Oh, you gotta count them?
Yeah.
Why?
Usually says it on the bag.
Look up here. Back up here. All right. Serving size is how many pieces?
4.
And how many servings per container? This
9.
bag's a container,
9.
right? So we got 4 in each serving size, and we have 9 servings in this bag, approximately. So what are we gonna do? 4 times 9 is?
36.
It's about 36 marshmallows, right? And approximately, because the way the guys, when they fill these bags up, you think somebody's gonna stand and count out 36 marshmallows and put them in here?
They just put them in and try to make it the same.
Try to make it the same? Right. So what they do is they put the bag on a scale, basically, all right? And the machine, not some person, right? Because we're gonna have, first off, I don't want those guys handling my marshmallows. Machine's gonna dump marshmallows in there until it weighs the right amount, and it's gonna stop, and then they're gonna seal the bag up. And so we've got approximate numbers. All right, so now then, let's do one thing with my marshmallow. This is my test marshmallow. I'll tie a piece of string around it. This is a good test question, right? And I think sometimes it's been on the MCAS. If I take, and the reason I'm using the marshmallow instead of this piece of cork is because if I hit myself in the head, right, it's not going to hurt near as much. Right? So I take this and I keep going like this, right? And it goes around and around and around. Why is it going around?
Because you're swinging it.
Because I'm swinging it, but why does it go around?
Because it doesn't weigh that much.
Doesn't weigh that much? But this way probably, that doesn't weigh much more, but this piece of cork does the same thing, right? It goes around and around and around and around. Around and around and around and around and around, right? But why? Why does it do that? Why does it go in a circle? Well, the reason it goes in a circle is because there's two forces being exerted upon my marshmallow, if I use the marshmallow in, right? There's one called centrifugal force, which is a force that's pulling it out that way, and another one called centripetal, which is a force that's pulling it back in. So the centrifugal force makes it go out, pull out, and it can't go anywhere but around in a circle because of the string, right? It's doing a centripetal force on it, so it makes it go around and around. Same kinds of forces that make the moon go around the Earth, and the Earth go around the sun, and all those good things, and all the little satellites we put up there, right, so that you could watch the bowl game, right? They're going around and around too, around the Earth, and the same forces operate on those satellites as operate on the moon, the Earth, they're going around the sun, right, and so forth, and all the other planets. So, now, the question is this going around? It gets right here, right, as it goes around. It's come around like this, comes around here like this. And right here, the string breaks. What happens to the marshmallow?
Falls.
Hmm?
Falls.
Where does it go?
It goes straight.
You think so? It's going to go out straight out this way?
Yeah, and then it's gonna keep on going down like that.
I
Okay.
think I'll go down.
It's going to go fall down it because we're standing here on Earth and there's gravity pulling down on it. So you think that if this thing goes around like this and the string breaks right there, as it gets around going towards the camera, the marshmallow is going to go that way and bang into the camera.
I
You
think
think
I'll
that's what's
go that way and just fall.
Why doesn't it keep on going in a circle? Was the string breaks?
No.
Well, because there's no force to make it pull around and go in a
Yeah.
circle. But you think it's going to go straight out, right? Why? So we got a couple choices here. It could keep going around in a circle, or if the string breaks, it could go straight this way, right? Hit her right in the nose. It broke right here, right? Or it could just go off in a straight line this way. Well, what actually happens if we look over here, right? Here I am, right in the center of the circle. Here's my little piece of string, right? Up here, and my marshmallow in this particular case is red, right? And I'm swinging around, it's going around in this direction, around, around, around. And you said if a string breaks, it's going to go off this way?
No, I'll go B. I'll go.
You think it goes B?
Yeah.
Right, why can't it go C?
Because there's no force.
There's no force
Swinging.
pulling it down towards the center, right?
Yeah.
The reason the moon's going around the Earth and orbiting around the Earth is because we got a force, we got that piece of string. What's that piece of string in the case of the moon? Gravity, right? Pulling the moon in, it's constantly pulling it towards the center of the Earth. But this thing is also traveling in this direction, right? So what happens if the string breaks, really? Okay, the answer is, you're right, it's B. It goes off in a straight line. So if I'm swinging it around, right, and it comes over here and it breaks right there, it's not going to hit her in the nose, right? It's going to go off in that direction.
Yeah, because you were doing it in the first place. So
Right.
You
Okay. Very good. Now, what we're going to do is we're going to build a catapult. Right? We're going to launch marshmallows. Okay? I have this thing, this little beam. I got a little platform up here for setting my marshmallow on. Right? I got this thing here for it to rock around like this. What is this anyway?
Like a pulley.
It's like a pulley? Well, it's a simple machine, but it's not a pulley. Remember back, 6th grade. This is called, what's this thing that it pivots around called? You remember?
Level thing.
It's a lever, right? And this part here is, this is the fulcrum, right? And we've got it's like a seesaw. It's like a seesaw, right? If we were put the fulcrum back here in the middle, it would sort of balance. But we've got a lever, right? And this is my fulcrum, right? So that what can happen is,
I get it.
huh?
Now I know what it is. When you go when you put something heavy and then it goes front.
Right, yeah. If I push down here like this,
Yeah.
all right, it's going to go up like that, right? So now if I push real slow here, right? Does that end move at the same speed? If I push this down 1 inch, what happens over there?
It goes faster.
It goes faster, right? So if I push down here with some force, right? This is my input force to the lever, and this is my load over here. This part over here goes real fast, right? So I must be able to use that for something, right? Besides hitting the baseball, right? With the ball bat, or fishing. Right? My fishing pole is a lever very similar to this, right? And what happens with a fishing pole, I take it and I go, and it goes, we have a piece of string or fishing line, the weight on the end of it, and then I go like that with the fishing pole. The tip on that fishing pole is moving pretty fast, right?
Yeah.
Right? And the sinker and the bait and everything goes out at some distance. So, well, it's sort of like a catapult. So what I'm going to do is I'm going to build a catapult. Right? This little piece of wood, I got some cardboard things, and I got some hooks. I built most of this so that we don't have to spend time building here. So now then, what have I got? I've got a lever. Right, now how am I going to make this thing go up and down? What else do I need? You want to give me some idea maybe what else I need?
A rubber band.
Rubber band? Do I have any?
Yep.
Where? Oh, I have a whole bunch of them, right? No.
I think this will go right there, and then I'll go over here.
Okay, so you think I'm going to hook the rubber band up
Yeah.
to this end, okay? And so maybe you want me to do that now?
Mm-hmm.
All right. So let's do that. Now what do you want me to do?
Put it like this, and then put the marshmallow there.
Okay, you want to put it down here like this, right? Right. I'm just going to hold it. All right, it is fixed up so we can put a piece of string around here and hold it down. But I'm going to hold it down. Now, what did you do when you did that? What happened to that rubber band?
It's forcing
Stretching.
the stick down.
Huh?
Yeah, it's forcing the stick down, so when you let it go,
But what happened to the rubber band right now? Right now,
it's stretching.
the rubber band is sort of sitting there, like you
Yeah.
are, relaxed. Right? And I give you some homework, and what happens? The tension builds up.
Yeah.
Right? So, what happens if I pull this down now? What's happening to the rubber band? I'm stretching it out?
Yeah.
And what am I doing when I stretch that rubber band?
You're forcing it.
You're forcing the lever.
What did you do with rubber bands in the classroom the other day? About a week or two ago. Did you do that?
Oh, for the airplane thing.
Yeah, for the airplane thing. What did you do with the rubber band?
We forced it to hit Mr. Richards.
Okay, so you shot Mr. Richards with the rubber band, right? The
Yeah.
whole class did, right? But he was pretty smart. He was standing back far enough. He knew that you weren't going to be able to hit
Yeah.
him, right? But what were you demonstrating when you did that?
To force the front
What happens?
By the
What
back.
happens when I take this rubber band and I go like this? I'm putting, what was it?
Pressure.
Pressure. You got the right word. It's P, but potential.
Oh, potential.
Potential energy, right? When I stretch this out, I got potential energy. When I let go of it, what happens to it? What kind of energy do I have then? Kinetic,
Yeah.
right? So what happens? Same thing here. And energy is what? The capacity to do work.
The
right?
work.
So if I take this and I pull this down like this, what I'm doing is I'm putting some potential energy into that rubber band.
When you let it go, it's gonna
When
be
I gotta let it
kinetic.
go, it becomes kinetic energy, right? And it does some work. And the work we want it to do, when we do that, is to launch my marshmallow. All right? So if I get my marshmallow back. So if I take my what happened? I had a catapult launched.
Yeah.
All right? And they used to use those back in the early days in warfare, right? They throw big rocks over the castle walls and hit people and so forth, right? You know, flaming buckets of oil and what have you. So that is my. You want to build one? Here. You want to build one?
How do you do this again? With the rubber band?
Oh, what I did is I just took it and I made a loop like this, right, and put it over the end of the lever. Slip that over there like that.
Like this?
Here, use mine. Excuse me. There. See how that's done now?
Yeah.
Okay. We're gonna have a contest. See whose catapult works best.
There.
All right. You get it? All right, let's turn, but don't shoot yourself. We're gonna turn it around this way. You get a marshmallow. You get a marshmallow. I get a marshmallow. I have one that I lost somewhere. All right, see that camera person over there? When I count to 3. Whoops. 1, 2, 3.
Oops.
Who did the best?
She did.
Oh, look at mine. Mine's way back there. Mine went better.
Oh, yeah.
All right, so let me ask a question. You're not much of a warrior, right? You better stick to baseball or something. Okay, so now, how can I get, our marshmallows are only going so far, right? How can I get the marshmallow to go a little bit further with this fancy machine that I have?
By getting a shorter rubber band.
Shorter rubber band, or
Yeah.
maybe put more rubber band. So what you're telling me is if I take and I put
Like if you,
Couple-
like you make it, like if you twist it more, it'll be littler and then you'll be
Yeah,
able to go faster.
or I could put another one maybe,
Yeah.
right? Put 2 of them on there instead of just the one, right? So you're saying if I shorten this up then and I stretch it, I'm going to put more potential energy into it. So when I let go, the kinetic energy is going to be greater and the marshmallow's going to go further. Is there any other thing I could do to my catapult to make that marshmallow go further?
By putting the lever more down, but you can't because
Put it more down? What do you think, Claudia?
As I think the same thing as he does.
No.
Oh, the rubber band.
What if I made, we said, I'm going to leave mine set up so that we can load it real quick in case those people out there get nasty, right? I said before, here's our fulcrum, right? And if I move this just a little bit, right, what happens to that end over there?
It goes faster.
It goes faster, right? What if I made this part longer?
It will go more higher.
It would go more higher, but it would also go faster, right?
Yeah.
Right, so one of the ways I could make the marshmallow start off when it started off go faster is if I made this a little bit longer, right? The only problem with when I make it longer, then what I really have to do, we can't do it because my arms are all the same length here, we'd have to put more force out here,
Yeah.
right? Because it would take a lot more force to get this marshmallow moving, right? But it would move faster. So we made this longer, right? We put more force here, we can make the marshmallow go a lot further. Now, anything else we might be able to do to it?
I think that's it.
Do you think that it makes a difference that whenever I let it go and the rubber band pulls it down as to whether it stops here, here, or here? Does it make a difference in how far the marshmallow is going to travel?
It matters because since it hits this, then
Right.
it'll give more force. Like,
Right, but so if I were to put something underneath here so that this would only come down this far, right? What do you think is going to happen?
it's just gonna go up and then come back down.
It's going to go up and come back down, right?
Yeah.
It's not going to go that way, hardly. Right, what about if I take it and I bring it all the way over here?
It'll go further.
It's going to go further?
Mhm.
You sure?
Yep.
Right, so this, right over here, and it comes over here and stops, the marshmallow is going to go off in that direction, right?
No, I think it'll go down.
Well, gravity's going to pull it down, but
Yeah.
I mean, but as soon as it leaves my little platform
It's
here,
just gonna go.
it's going to go this way and then fall down, right?
Yeah.
Right, what about if I take it on and bring it up here about this far and stop? Right, then the marshmallow is going to do what?
It's gonna just go up.
It's going to go up in that,
Like that.
sort of in that direction, right? So which way do you think it's going to travel the furthest that way? If I stop
If you stop here,
here,
no, in the middle.
in the middle?
Yeah.
What makes you say in the middle?
I just think that will go further if it stops in the middle.
What
In the
about
middle.
if it goes over here?
It'll go far, but not. I think the middle will go further. Than,
I want to know why you think that. You happen to be right, right? But why? Why do you think that?
Cause it's gonna hit this, and then it's just gonna go, and then it's gonna make it slow down.
Okay, but if I were to put something here and make it stop right there, so it couldn't go any further, it hits something down here.
Cause it's in midair. If you put it right, like all the way in the top, and it's just gonna go down straight.
You happen to be right. It's going to be easier for us to see this, okay? I have a little air pump rocket, right? We can't demonstrate it too well there because we don't know how fast the marshmallows are actually leaving. But this thing, the way this works, right, is a little piece of foam rocket, right, pretty soft. Won't hurt you if it hits you in the head again. All right, we put it down on here, all right, and it's going to take a certain amount of force to push this off, right? Try it, take it off. It takes a certain amount of force to get it
Yeah.
off. So what happens, the way this thing works is if I pump this up with air pressure, right, when the pressure gets to be a certain amount, it's going to force this off, right? And it's the same amount of pressure whether it's up here like this, down here like this, or here like this.
In
So,
the middle, because
so this leaves, all this is going
if
to
you
leave.
leave it on top, it is gonna go up and come back down.
Okay, so what you're saying is if I take this and I go like that, it's going to go up there and hit the wall, hit the ceiling rather than not
And
the
come
wall.
back.
That's the ceiling, right? And come right straight back down.
Yeah.
Right? If I take it and I'm gonna have to back up here a little bit, right? So that it is that we take it like this and it comes off. What's going to start happening immediately?
I go down.
Gravity's going to start pulling
Yeah.
it down, right? So it's not going to go as far if I take it like that, right? It's only went that far. But if I take it off at, and we're going to shoot it out towards the camera, so maybe they'll retrieve it for us, right? Give it back to us so we can play some more. But if I take it like this at 45-degree angle, off in the middle, like you said, you think it will go further?
Yep.
All right, watch how far it goes this time. Way back behind the cameras, right?
Always right.
You were right, okay? So, when he's not going to make the major leagues. Right. So, right, what happens is if you take it, if our catapult comes up, it stops. This is about a 45-degree angle, right? You had angles, right? 45-degree angle on a catapult, right? With the same force on the elastic band, right? Same weight, marshmallow. At that point, it's going to stop. The marshmallow is going to take off, and the marshmallow is going to take off, and it's going to take off at a 45-degree angle, just like my little rocket ship.
Yeah.
All right. So at that point, it's going to go the furthest.
Yeah.
If we let it off there. In fact, a lot of the guided missiles, right? Some of the earlier ones, the newer ones, are a little different, right? What they do is they launch them like this, right? And they go up, right? Go up like this. When they get up to where they're able to fly stable,
Yeah, they drop.
well, what they do is they tip them over at a 45-degree angle, right? And the rocket engine is still burning, so now we know it's going to go as far as the maximum distance, right? So we can get the maximum range out of it. So, now, if we take a look at all that, get all my charts right side up. If my little rocket takes off, right, and it goes off, this is a 45-degree angle here, right? That's a 45, isn't it? You did these graphs, right? So if my rocket takes off, it goes along this line, right? And it's traveling at a certain speed or a certain velocity, right? That's the length of the line there. It also has a velocity up this direction and it has a velocity this way. Right? If this is the Earth down here, what's other force we got on this rocket as it goes across? What makes it fall down?
Yeah.
Gravity, right? Right, so what's going to happen is gravity is going to start pulling this down like this, right? Canceling out this velocity, and eventually it's going to come down and hit the ground.
Yeah,
right? Because it's
it doesn't got force, more force than the gravity.
right. There's more force than the gravity, right? So now going back to what kind of marshmallow is this?
Big one.
It's a standard marshmallow, right? How many pieces in a serving?
They're 7.5.
All right, it weighs 7.5 grams, right?
Yeah.
And in each serving, for the number of calories and all the nutrition, if marshmallows have any nutrition, they don't have much. There's 4 pieces, right? And we had 9 servings in a bag, so there must be
36.
about 36 marshmallows in the bag. So if I take now and I take my marshmallow, all right, and I pull it down here like this, what is happening here? I'm stretching that rubber band, and what am I doing?
Potential.
I'm putting potential energy in it, and I let go of it,
Kinetic.
and it becomes kinetic energy, which does the work,
Yeah.
right? Because energy is the capacity to do work, and how much tension we put on this glass,
Stretching.
how much we have to stretch it, how much energy we have
Yep.
to put into it to stretch it, is going to determine how much kinetic energy we have. So if I put more rubber bands on here, right, it makes it harder to stretch. I'm going to store up more energy. I'm going to have more kinetic energy to release, right? When I let go of it. And if I let go of it, what's going to happen to my marshmallow?
Gonna fly.
Well, first of all, this is going to pull down here, right? And as this pulls down, what happens to this end? It's going to go up. Does this end go up the same speed as this end?
Nope.
Goes down? No.
That one goes faster.
That one goes faster, so that's going to make the marshmallow go faster, right? And get it further out there before gravity pulls it down and makes it hit the ground. Right? So if I let go of my marshmallow, and it's over there somewhere, right? And you correctly said that if I take and I launch this thing off straight up, it's going to go straight up, it's going to come straight back down, and it's not going to go anywhere off in that direction. If I take it and launch it like this,
It's gonna go straight.
it's going to go straight, and
gonna go
gravity's
down.
going to pull it down, and it's going to hit the ground much quicker. If I want to make it go as far as I can make it, what do I do? At a
In the middle.
45-degree
Yeah,
angle,
put
right?
45 degree.
And it goes off
Yeah.
over there somewhere, right? So, right. That's it for today. You gonna go home and build one of these now? No? You're not gonna go home and show your parents how to launch marshmallows? No? Okay, I guess not. How about you?
Don't eat the marshmallows.
You don't eat marshmallows? They're not very good for you. They're all sugar.